Good afternoon, everyone. Welcome to today's Yebo Physics session. My name is Lucian Pullen, and this is actually my first session because last week I had to help out at the Nelson Mandela Open Day, Nelson Mandela University Open Day. So, yes, to those of you, there are currently no viewers, but to those of you who will be watching this sometime in the future, my name is Lucian Pullen, and I'm currently doing my master's, my second year of my master's in physics. Okay, so I am one of the Yebo physics tutors along with Arnold, Zola, and Dr. Jenna. Okay, Zola, of course, is Dr. Ugesa. He prefers to be called Zola. Okay, now up to this point, you guys have done the basics around physics, and I will be helping you guys with some of those basics. Okay, now as soon as you join, or if you're watching this in the future, obviously you cannot ask me questions, but if you're currently watching this live, then, which at the moment there is no one live, but let's see. Okay, I'm just certifying. Yeah, there is currently no one viewing except myself, but yes, at the moment we are using or revisiting motion in 1 and 2 dimensions for PHYV, and then for FVV we are doing a revision of vectors. Okay, motion in 1 dimension for Prof. Gibbons' class, the PHYV students, and then a revision of vectors for the students in Dr. Vestra's lectures. Okay, now we'll start with the PHYV questions first of all. Okay, let's see. Okay, this is very straight. Let me just angle myself. Okay, now I can write down. We are going to your questions on Moodle. Okay, the question is there on your screen. It should be displayed on your screen there. It is question number 13. Question 13. Okay, these questions will be on one-dimensional motion, and I'm going to try and write as big as I can. Okay, now I have apologized in previous sessions last year for sometimes my handwriting is not the best, but yes, I try. So the question reads as follows: the position of a particle moving along the x-axis is given by x is equal to 6.0 t squared minus 1.0 t cubed, where x is in meters and t, the time, in seconds. Okay, so the position of a particle given by x can be calculated using that formula, 6.0 t squared minus 1.0 t cubed, where x is in meters, meaning the position is in meters along the x-axis, and the time in seconds. Now, what is the position of the particle when it achieves its maximum speed in the positive x direction? Okay, so what is the position? The question is, what is the position of the particle when it achieves its maximum speed in the positive x direction? Now, let's start with what we are given. Okay, we are given that the position is equal to 6.0 t squared minus 1.0 t cubed. Now we can just write this as x is equal to 6t squared minus t cubed. It's the same. Okay, now we wrote down what we are given. It's always helpful to write down what we are given and what you want. Now we want the maximum speed in the positive x direction. Okay, now let's just a quick refresher. Okay, on a position time graph. Okay, let's say this is a position time graph. Let's say this is some position time graph. This is some, let's say this is position X or position or X, if you will, and this is the time. Now on a position time graph, the position changes as time goes on, obviously. Now, the point on this position time graph where this speed is a maximum, or where it will achieve its maximum position, is when the acceleration is 0. Okay, now the derivative of a position time graph, the derivative of a position time graph is equal to the velocity or the speed. Okay, now let's say we have a velocity or speed time graph, okay, and we have some function. Okay, the derivative of a speed, the time rate of change of speed, is just the acceleration. Okay, so just a quick refresher, okay, that the derivative or the slope or the rate of change of position is speed, and the rate of change of velocity is acceleration. Okay, meaning the slope of the tangent line to each of these position time curves or velocity time curve would, the slope of the tangent line to the velocity time curve would be the acceleration, while the slope of the position time graph would be the speed or the velocity, depending on if you're working with, position, then it's just the speed, but if it's displacement, then it's the velocity, obviously. Okay, so let's see. Now we already have what we formulas for speed. It is just the derivative of the position, the time rate of change of the position, or the derivative dx dt of the dx dt is equal to the speed, and then acceleration is dv dt. That is all you should take away from these graphs. These graphs I just drew for some interest. Okay, now when will a particle achieve its maximum speed? Okay, when its acceleration is 0, meaning it's not speeding up anymore. Okay, when will it achieve its maximum speed? So it achieves its maximum speed, the particle will achieve its maximum speed. The particle will achieve its maximum speed when the acceleration is equal to 0. Okay, so the particle will achieve its maximum speed when the acceleration of that particle is 0, meaning it can't go any faster. It's not accelerating anymore because it's at its highest speed. Now let's first calculate. In order for us to calculate acceleration, we know that acceleration is equal to, we know that position x, let's scratch it out, x, we know that x is equal to 6 d squared minus d cubed. Okay, now the derivative dx dt is equal to speed. Okay, speed is equal to dx dt, okay, which is equal to d dt, you know your math, of 6t squared minus t cubed. Okay, so the time derivative of this function will give you the speed. Okay, so this is 12t, and that is going to be 3t squared. So there you have it. We have the speed. This is the formula for the speed. So now we have a formula for position. we have a formula for speed. We want the formula for acceleration because the maximum speed is obtained when acceleration is 0. Okay, so acceleration is equal to dv dt, as I iterated earlier on. Okay, so dv dt is equal to the acceleration. Okay, so that is just d dt of this, the speed. Okay, 12t minus 3t squared. Okay, now this is just equal to 12 minus 6t. So there we have the acceleration. Okay, so the acceleration, that is v speed, and that is the acceleration. Okay, the acceleration. Okay, I'm not going to write out the full word. So now we have three formulas: one for speed, one for acceleration, and one for position. Okay, now they want the position of the particle when it achieves its maximum speed. Okay, so at what time does it actually achieve its maximum speed? We've already said that it achieves its maximum speed when the acceleration is equal to 0. Okay, so when 12 minus 60 is equal to 0, then it will achieve its maximum speed. I'm going to move it up now. So when the acceleration is equal to 0, that's when it will achieve its maximum speed. So 12 minus 60 is equal to 0. So if you solve for t, then you have that 12 is equal to 6t, or t is equal to 2 seconds. So when at 2 seconds, this particle will achieve its maximum speed. So this particle will achieve its maximum speed at 2 seconds. So they want the position it is when it achieves its maximum position, when it achieves its maximum speed. So all you do is you plug it into, this is the formula for position, minus t cubed. So all you do is then plug in for 2 seconds, see where this particle will be after 2 seconds. Okay, that is 6 times 2 is 12 minus, that is 8. So 12 minus 8. So it is at, sorry, this is 6 times 2 squared. Okay, sorry, so 6 times 4. 6 times 4, that is 24 minus 8. And that gives you 16 meters. So this thing will be 16 meters along the x-axis when it achieves its maximum speed. Okay, I hope everyone understands that. And if you have any questions, please stop me so that I can explain the question again. I'm going to go over the question again. The question was, at what point does this particle achieve its maximum speed? Now we know that the particle achieves its maximum speed when its acceleration is 0, meaning it's not accelerating anymore. Okay, its acceleration is 0. Okay, meaning on the speed time graph, it will be where it is, the gradient of the slope would be 0. Okay, so when this particle is not speeding up anymore, that is its maximum speed, it's not speeding up anymore. Okay, so speed, we have the position formula given to us, but then we can derive or calculate the formula for the speed. It is just the time derivative of the position, okay, which is d dt, and we calculate it to be 12t minus 3t squared. Okay, and then if you go ahead, if you want the acceleration now, which is what we do want, because when the acceleration is 0, then it is at its maximum speed. We've calculated the formula dv dt, which will give you the acceleration, which is nothing but d dt of 12t minus 3t, which is the formula for the speed. And we got the acceleration as 12 minus 6t. Okay, so there we have a formula for acceleration. Okay, but we want, when is this acceleration 0? Okay, at what time will it be 0? So the acceleration is equal to 0 when 12 minus 60 is equal to 0. Okay, so at what time? We calculate the time to be at 2 seconds. At the point 2 seconds, this acceleration will be 0. But the original question asked at what position. So we take 2 seconds, After 2 seconds, it will achieve its maximum speed. But at what position will this particle be after 2 seconds? So we plug it into the position formula, and we got that the position this particle will be after 2 seconds is 16 meters away from its starting point. Okay, and that is how, ladies and gentlemen, we calculated the position of this particle when it is at its maximum speed. Okay, now let's go. The radius, they ask us the next question, question number 14. I'm going to give you a break quickly to digest that. The next question, question number 14, I'm going to give you a few minutes. If there is anyone who would like to ask anything, please do so. If you have got nothing to ask, then by all means, just listen, please. Now, let's go on. Question number 13, I'm going to leave it up for a few seconds. If you want to attempt it in those 1 or 2 minutes, I will leave it up there. Okay, by the way, you got 16 meters. Let's see. Check. 16 meters. The correct answer is 16 meters. Okay. So the next question, I will leave it up there. A car travels counterclockwise around a... Let's not read it now. That is the question. Question number 14. Question 14. Okay. So question 14. Now, leave the question up for a few minutes, 2 or 3 minutes. Then for those who want to attempt it, please feel free. Okay, I'm going to read the question, then I just need to open separate copy. Okay. Okay, question 14. The question reads as follows. Okay. A car travels counterclockwise around a flat circle of radius 0.25 kilometers. So a car travels around a counterclockwise around a flat circle. So around a circle, the car travels counterclockwise. Okay, so opposite to the direction the hands of a clock would travel. Around a flat circle with a radius of 0.25 kilometers. Okay. Now the car, when the car is at point A as shown in the figure, what is the car's acceleration? Okay, so you have a formula for radial acceleration. Okay, the formula for radial acceleration says that it is its linear speed divided by the radius. Okay, it gives you your radial acceleration. Okay, now the linear speed is, or the speed that it is traveling at, is 20 meters per second. Okay, the radius is, in this time, that is squared. The radius is 250 meters. Remember, we don't work with kilometers, we work with meters. Okay, 250 meters. That will just give you 400 meters squared per second squared. So if we got an answer, the answer would be in meters per second squared. Okay, so it is 1.6 meters per second squared. Okay, that is the answer to this question number 4. Okay, now that was the easy part. Okay, we got that the formula for radial acceleration is easy to calculate. Okay, what is the car's acceleration? Okay, what is the car's direction at point A? Okay, the car's direction at point A, you see it is currently still going counterclockwise, meaning it is currently turning towards the center of the circle, meaning at point A it is still turning towards, it is accelerating towards the center of the circle, meaning at that point, at point A, it is turning towards the center of the circle, which is west of point A, so it is going west. So 1.6 meters per second squared west. Okay, if you have any questions regarding that, please let me know. Okay, so let's check the answer. .6 meters per second west. 1.6 meters per second west. Let's see. 1.6 meters per second squared west is the correct answer. Okay, now question 15. Okay, we are going through these problems awfully fast. This is question 15. Okay, I will leave it up there, but I actually need to do something else quickly. But I will do this quickly. If there are any questions, I'm going to give you 2 minutes to digest the previous problem. Okay. And that's the solution to the problem. If you have any questions, please ask. Obviously, if you're watching this in the future, you cannot ask me the live question, but I hope you understand. Okay, so 15. Question number 15. Question 15. Okay. Okay, we will be finishing these problems, then we're going to take some problems from the textbook for the next half an hour, then we're going to PHYV problems. Okay, so PHYV, this is for PHYV, and then the next is for FVV. Okay, so let's finish these questions for PHYV. Question number 15 asks, the initial speed of a cannonball is 0.2 kilometers per second. If the ball is to strike a target that is at a horizontal distance of 3 kilometers from the cannon, okay, so the initial speed of a cannonball is 0.2 meters per second. If the ball is to strike a target that is a horizontal distance of 3 kilometers, so let's say here's the cannonball. It has an initial speed of 20 meters per second. Okay, so V is an initial speed of 20 meters per second. If it is, it's 0.2 kilometer, sorry, it is 0.2 kilometers per second, okay. if the ball is to strike a target that is a horizontal distance of 3 kilometers away. So let's say here's the target. Let's make it a bullseye. Okay. Terrible bullseye, but bullseye nonetheless. It is 30 kilometers away. No, 3 kilometers away. 3 kilometers away. No, the distance, let's imagine there's a distance between them. Not imagine, but given that this, I mean, let's imagine that that's the distance between these two things. Okay, that I drew. What is the minimum time of flight for the ball? Okay, the minimum time of flight for this ball. Okay, the minimum time of flight, meaning as this ball is going, it is going to start slowing down due to resistance and stuff like that. So if we assume that its initial speed is constant, then we'll have the minimum time of flight for this ball. Okay, we know that time is equal to distance over speed. Okay, so what is the distance? 3 kilometers. What is the speed? 0.2 kilometers per second. The kilometers cancel out. 0.2 is nothing but 2 over 10, meaning times 10 divided by 2, so it is 15, if I'm not mistaken. 15 seconds. Okay, now this is where I have a problem with this, the answer here, because there is no option for 15, but the correct answer is 15. Okay, so I tried 14, it didn't work. 16 was apparently the correct answer, which it is not. The correct answer is 15 seconds. Okay, so just make sure of that. The correct answer is 15 seconds, not 16 or not 15. The correct answer is not 15 or 4, not 16 or 14. It is 15 seconds. Okay, you can work it out for yourself too. Okay, so let's see. We've done 3 questions that I was assigned to me for PHYV. Let's do some more questions from the physics textbook for the PHYV students to get them well acclimatized to these sort of problems. Okay, I have selected some problems you can work on. Okay, just give me 5 minutes while I sort out the problems. We'll do 3 or 4 problems, and then we'll move to the ZTM the PHYV workbook. Okay, we are doing motion in 1 dimension, or in 1-dimensional motion. Not yet 2-dimensional. Okay, still 1-dimensional motion. Right, projectile motion. This is projectile motion. So yes, it is 2-dimensional motion. And it is 2-dimensional motion. Let's do some projectile motion problems from the book, and then we will do Before we do that, let's do a problem similar to the one we covered based on since you have all done vectors, so you should be in the first. You guys seems to have struggled with vectors. We will do some vector problems, okay, and then we will move to some problems on. I'm going to show you guys now. We're going to do some vector problems and then we'll move to some problems on. Yeah, a lot of these questions are graphical techniques and okay, here we go. We're going to do some vector problems and then we'll move on to some one-dimensional motion problems. Okay, just highlight the question and then show you guys what I've highlighted. Okay, let me just make it smaller so you don't see the whole thing. Still see my document writing pad. Okay, it's about there. Let me just put my face. Okay. For some reason, some of the apps around this thing are just opening up. Question number 15. Some basic vectors. Okay, we'll be doing some basic vectors. Okay, where is face cam? see. Question number 15. A vector. Question 15. In Survey and Jewett. These are Survey and Jewett problems on vectors because you guys have a very lackluster understanding of Survey and Jewett problems on vectors. Okay, this is on vectors. These are Survey and Jewett problems on vectors. Okay, this from your lecturers have instructed us to please revise some concepts regarding vectors. Okay, so these are Survey and Jewett problems on vectors. This is on section chapter 3. Question number 15. Okay, so we'll start with question 15. Okay, the question reads as follows. Okay, a vector has an x component of negative 25 units and a y component of 40 units. Okay, find the magnitude and direction of this vector. Okay, so let's try and draw it. So this vector, let's choose to the right as positive and upwards as positive. Okay, these are the usual choices, as positive and that to the right is positive. Okay, so 25 units, negative 25 units meaning 25 units it's to the left. Okay, so 25 that way, and then 40 units, positive 40 units, that is 40 units up, 40 units. Okay, units and then 40 units. Okay, so the resultant vector would be then this vector here. Okay, I wonder if I should draw it with my cookie pen. Let's see. This would then be the resultant vector going that way. From there to there would be the resultant vector. Okay, R resultant. Okay, it shows up yellow on your screen. It's actually green. Okay, that will be your resultant vector. Okay, and we want the magnitude and the direction of this vector. Okay, that is theta. Okay, so what is the magnitude and the direction of this resultant vector? Okay, now I will give you 1 minute for those of you who want to attempt it, or you can just pause after a minute. I'm going to answer it. Okay. This is negative 25 units, by the way, meaning it is 25 units in the negative direction. Okay, if this was, say, the Cartesian plane, this was the origin, that is the origin. Okay, this will be negative 25, that would then be 40. Okay, so we want theta and we want the resultant. Okay, the value, the magnitude. Okay, magnitude of R is equal to this squared. It would be this side, the x component of the vector squared plus the y component of the vector squared, and then the square root of that. So it will be the x component of the vector squared, so r x squared plus r y squared, and then the square root of that. Okay, so let's see, the square root of 25, negative 25 squared plus 40 squared is equal to, that is the square root of 25 plus 40 and that is, let's see, okay, let me just check my calculator quickly. The answer is, I didn't do this part, this step, but the answer is eventually is 47.2 units. Okay, so that is the magnitude of the resultant vector. Okay, the magnitude of the resultant vector is 47.2 units. Okay, what is this? That is 25 times 2, 25 times 25. Just check one more before I lie to you guys. I used to display a calculator. It's not there. I don't want to display it this way. There it is. I'm going to put it there. Rather remove it. I don't want to display the calculator now. Okay, let's see. Okay. This is why I should always bring my calculator with me, but I forgot it today because I was tutoring the PHYB students, SI tutoring them, and talking about exercise. It's a very good. Now the next thing is 40 squared, 1600, I presume. 1600. It gives you the square root of 47.2 units. So that is the actual value for the magnitude of that vector, okay, that we just got. So we were given some vector with its components, and then we had to calculate the resultant. Sorry, and I accidentally just showed you the manual as well. Okay, I just needed to check that. So, but we already calculated it, so we can then now go ahead and calculate the next value. Okay, let me just close. Yeah, I also have the manual. Let me just close that. Right now, let's calculate. Of course, we need this angle here. Okay, we have the resultant which we calculated, okay, using the Pythagorean theorem. And then here we need this angle. Okay, now from high school you remember that you calculate this angle using the tangent. You can also use sine or cosine because you already have the resultant value. Okay, the value for the resultant R is 47.2 units. Okay, now this angle, the tangent of this angle is equal to 40 over 25. Okay, so let's see. Okay, So it is going to be the theta is equal to the second function tangent of 40 over 25, because we are not interested actually in the moment at the negativity of this angle, or y is negative. We'll just subtract 180 from the angle from 180, and we'll have the angle from the positive axis. That is the angle that we want, okay? But this direction, we want to measure it from the positive x angle, but we first need this theta, okay? So the second function tangent of 40 over 25 is equal to 58 degrees, okay? Now 180 theta, so this angle here, this one is then equal to, let's call it phi. So phi is then equal to 180 minus 58, okay, and that is equal to 22, okay, 122 if I'm not mistaken, okay, 122 degrees. So that is the angle there, phi, 122 degrees, okay. It's not that difficult, it's reasonably easy, okay? It's a very simple question, and yeah, let's move on to a much more, a bit not challenging, it is still easy, but let's move on to another question, okay? Let's see. I am doing a lot of these problems because I originally prepared a lot of vector problems, not vector problems, two-dimensional motion, but I understand you have only just started it, as I gather from Dr. Bestrad. Now let's do some breaking a vector into its components, okay? Question number 16. Breaking a vector into components. Question number 16. Okay. A vector has an x component of negative 25. So an x component of negative 25. So it is 25 in that direction. That is wrong. I wrote the first question again, or 15. Again, apologies. Question number 16 states that vector A has a magnitude of 35 units and points in the direction 325. Okay, so that is in the fourth quadrant. Okay, so this we have some vector counterclockwise from the positive x-axis, counterclockwise. Okay, so let's say this is the Cartesian coordinates. We have some vector with a magnitude of 35 units and it points 325 degrees. Now this is 90, 180, 270 and 360 is there. So this vector will be somewhere here. This vector A will be somewhere here. There is the vector A, and it is measured from the positive x-axis, and that value is 325 degrees. Okay, so there we have that angle, okay, that vector A. Now they ask us, it is counterclockwise, so opposite to the direction within which the hands of a clock will travel. Okay, it asks calculate the x and y components of this vector. Okay, so this vector, so first of all we need that angle there, theta. Okay, so first we need to calculate theta. Okay, then we can calculate, this is the x component, a x component, and this will be a y component, okay, that is 90 degrees. Okay, first we need theta. Theta is equal to 325 degrees minus 270 degrees. Okay, now I keep, okay, let me just use the online calculator. That I've set up here. So let's see. Let's use Desmos. It's a very good scientific calculator. And yeah. So it is 325 minus 270. It's 55 degrees. So this angle of theta is 55 degrees. Okay, so to break it up into components, we know that the horizontal component or the x component of that vector is equal to ax over a, the magnitude of a, and that is equal to the sine of theta. Okay, so the sine of theta is equal to ax over the magnitude of a. And now ax is what we want, but the magnitude of a is equal to, we have been given that it is 35 units. Okay, let me just highlight that question. Just remove this one and highlight that one. They want the vectors, the x and y components. Okay, so, and that is then equal to 35.0. Okay, so the sine of theta, which in this case is 55 degrees, the sine of 55 degrees is equal to ax, which is equal over 35.0. Okay, so ax, the horizontal component of this vector, is equal to sine of 55 degrees multiplied by 35, which is equal to let me calculate. Where is my calculator now? Sine of 35. Okay, let's see. Next line. Sine 55 multiplied by 35. It is 28.6. So AX is equal to 28.7 units. Okay, units. So the horizontal component is 28.7 units. The vertical component, cos of theta, is equal to a y component over 35 units. Okay. Now the cos of 55 degrees equal to a y component 35, and that will give you the y component of that value is then cos of 55 times 35 units equal to. Okay, so let's see. There's my calculator. These are some basic problems, guys, but that I am doing. but with good reason, as you seem to have struggled in some of the assignments, breaking them up into components and then answering. Okay, or working with vectors in general seems to be a bit of a challenge. Okay, so that is then 20.1 units is the answer for this vector. Okay, the y component of this vector. So we have the x component, which is 28.7 units, and then the y component, which is 20.1 units. Okay, and that is problem 16. Okay, but since the y component is pointing downwards below 0, so we can just also write it just as negative 20.1 units. Okay, so which indicates that it is downwards. Okay, so I'm going to take a small water break now, and then when I come back we'll continue with some more problems on vectors. Okay, but let me just put up the next problem, so those of you who might want to attempt it, this is question number 23. Okay, adding, subtracting vectors. This is always sometimes a problem for students, so I'll leave it up there so we can attempt them. Okay, I will be back in about 5 minutes. Just need some water for my throat. guys, I'm back. Just lubricate my throat for a bit. We can continue now. Let me just check if there are any newcomers. Any questions? Nothing. Okay, so let's say I also need to do something else while you are busy with that problem. Let me check something here. So far, yes. Okay, let's continue. Okay, so this question on vectors. We consider the two vectors A. This is question number 23. And the reason why I'm revising vectors is because you need a good solid understanding on vectors before we can actually jump into as projectile motion. You need a good grounding in vectors. Okay. So this is vectors in unit form, which I assume this is some of your first time we'll be doing it. So a vector has, so far, the reason why I did the problem before this is to show that you can break a vector into its components and then use components to calculate the vector. Okay, now we can also denote a vector in terms of its vector components, meaning in the I hat direction it is in the x direction, meaning horizontal, or usually it is horizontal if it's two-dimensional, and then in the j hat direction vertical if it's two-dimensional. Usually, it doesn't always have to be there, it's usually. Okay, so we have vectors can be in the I hat direction and in the j hat direction. Okay, now one thing you need to do, very important, you can only add or subtract you can only add, this is question number 23, can only add or subtract vectors that are in the same direction, meaning now since I hat denotes a direction and j hat denotes a direction, you can only add I hat to I hat and j hat to j hat. You can't add j hat to I hat vectors. So that is basically what I want to say there. So we have two vectors. We are given that vector A is equal to 3 I hat plus minus 2 j hat, and I'm going to draw these two vectors, and B is equal to negative I hat plus, is it plus or minus? Minus. I'm moving the screen. I need to move it on this side, and you may see me looking from one to the other. I'm looking at two screens at the moment, so minus 4 j hat, okay, minus 4 j hat. Okay, so let's first draw these vectors. Before we do all the adding and subtracting. Okay, let's say that. Now usually this would say, let's say that's the I hat direction, this is the j hat direction. Okay, that will then be the negative I hat direction. This is negative I hat then, and this will be negative j hat direction. Let's draw A and B vectors, A and B. Okay, 3 in the I hat direction, let's say this is 3 in the positive I hat direction, and then negative 2. So let's say negative 2 and 3. That's where we have vector number A. Okay, this is not to scale. That would be 3 in the I hat direction and negative 2 in the j hat direction. Okay, so there we have vector number A. Vector B is also in the negative I hat direction, so it is somewhere here, it is negative 1, somewhere here, and then negative 4, somewhere here, around here. Let's say negative 4 is here. Okay, so because I drew it to that point, but it is negative 1, isn't it? Negative 1, let's say negative 1 is there. This is not to scale, remember guys, this is not to scale. Okay, that is then vector number B. Okay, vector B, sorry, positive B, not the negative B. Don't have to write positive there, that is a mistake, that is just vector B. It's denoted vector B. Okay, so these are the two vectors A and B. Okay, so what if we were to add A and B? They say A, let's add A. What is A plus B? Okay, how do we add unit vectors? Okay, these are vectors A and B, guys. I just drew them for you guys. Okay, vector A is 3 units in the I hat direction and then negative 2 units in the j hat direction, or 2 units in the negative j direction. Okay, so and there's the vector, it's its endpoint. And then vector B is 1 unit in the negative I hat direction and 4 units in the negative j hat direction. So there we have vector A and there's vector B. Now they're asking us, what if we were to add vector A plus vector B? So vector A is 3i hat minus 2j hat. Now remember what I said earlier on, we can only ever add vectors that are in the same direction. Okay, so I hat will be added to I hat and j hat will be added to j hat. This will give us the following, that is j hat, so it will be 3i hat, this is vector A plus vector B. If we lose everything up, we will have 3i hat minus I hat plus minus 2j hat minus 4j hat, which will give us 3 minus 1 is equal to 2i hat, and then minus 2 minus 4 is minus 6j hat. Okay, 2 minus 6j hat. Okay, that is the answer for A plus B. Okay, see, it was out of the screen for a moment there. A plus B is 3i hat minus 2j hat is A, which is A vector A, plus vector B, which is minus I hat minus 4j hat. If we add them together, we can only add vectors that are, or components that are in the same direction. So meaning we can only add i's to I hat to I hat, and j hat to j hat. So 3i hat minus 1 give me 2i hat, plus negative 2j hat minus 4j hat is negative 6j hat. Okay, so the next is they want us to calculate A minus B. Okay, so A minus B. So now you know the concept. You just add j hat to j hat and I hat to I hat. Okay, so it is now 3 I hat minus 2 j hat minus I hat minus 4 j hat. Okay, so if we multiply that in, we get 3I hat minus 2j hat plus I hat plus 4j hat. Okay, so it will then be equal to 4I hat, because that is, if we group them together, 3I hat plus 1I hat plus negative 2j hat plus 4j hat gives me the following answer. 3 plus 1 is 4I hat, and then negative 2 plus 4 is negative plus 2j hat. So 4 plus 2j hat. Okay, so there we have it. We've added these two vectors and we've subtracted these two vectors. What is the magnitude of the sum of these vectors? Okay, so the magnitude of the sum. Now we already know what the sum is. Okay, a plus b. Okay, we know they want the magnitude of a plus b. Okay, so the magnitude of a vector a plus vector b. So which is just equal to the magnitude of, remember we calculated the sum to be 2i plus 6j. 2i hat plus 6j hat. What is the magnitude of that vector? Okay, remember the answer is also a vector. Vector plus a vector is a vector. Okay, so how do we calculate the magnitude of a vector with two components? We use the Pythagorean theorem. Okay, so it'll be the square root of the I component, 2 squared, plus the square root of the j component. So it will be the square root of 4 plus square root of 6 is 36, is the square root of 40. Okay, and the square root of 40 is 6.32. Okay, so there we have it. Now same thing with, this is C by the way, the same thing with the difference between these two vectors, a minus b. The magnitude of a minus b is just equal to the magnitude of this vector, which is equal to 4i hat plus 2j hat. The magnitude of that vector is equal to just the square root of the square root of 4 squared plus 2 squared. That is equal to 16 plus 4, which is the square root of 20, which is between 4 and 5. So 4 point something, 4.47 it seems, is the magnitude of that vector. Okay, so now we've done some vector addition and subtraction component wise. Okay, let's do another vector problem. Okay, let's do another vector problem. We are doing vector revision over here, guys. I'm going to let you guys catch your breath and then we'll do the next problem. I think we'll do 3 or 4 more problems and then we'll call it a day. Okay. Okay, problem number 27 is similar to the one you had in Okay, we'll do problem 26 and 27. 26 is similar to the one we just did, And then 27 is similar to the one that you did in your test for the PHYB students. Okay. Okay. Resolving a bunch of vectors into a resultant vector using components. Okay. So let's see. Given the vectors A, we are given, this is number 26. Problem number 26 on vectors. Okay. We are given, let me just move this right here. We are given the vectors A. We are given the vectors A, vector A, which is equal to 2 in the I hat direction plus 6 in the j hat direction, and B equal to 3 in the I hat direction minus 2 in the 2 in the j hat direction. Okay, I didn't write the 0.00. Okay, so minus 2 in the j hat direction. Now the question is, let me just check if there are any questions. No questions. So they want us to do the following. Okay, they want us to calculate, given the vectors A equal to 2 I hat plus 6 j hat and B equals to 3 I hat minus 2 j hat, A, draw the vector sum C, which is A plus B. So let's first calculate and the vector difference. So we need to draw them, the vector sum of A plus B and A minus D, which is A minus B. So C is equal to A plus B. Okay, so let's add these vectors. A plus B is equal to 2 in the I hat plus 6 j hat plus B, vector B, which is 3 I hat minus 2 j hat. Okay, that gives us the following. We group I hat with I hat, which is equal to 2 I hat plus 3 I hat and plus 6 j hat minus 2 j hat, gives us a vector of 2 plus 3 is 5 I hat, 6 minus 2 is 4 plus 4 j hat. Okay, so there we have a vector. Vector C is equal to 5 I hat plus 4 j hat. Now what is vector D? They ask us also to calculate vector D, which is A minus B. It's a difference between vector A and B. So vector D is equal to A, vector A minus vector B. Vector A is equal to 2 I hat plus 6 j hat minus 3 I hat minus 2 j hat. Okay, if we group them together, first of all, let's group them. Let's first get rid of the everything. 2 I hat plus 6 j hat minus 3 I hat minus 2 j hat. If you group them together, 2 I hat minus 3 I hat plus 6 j hat minus 2 j hat. This gives you the answer of 2 minus 3, this is minus I hat plus 6 minus 2 is, that is 6 minus, sorry, that is a minus, so that becomes plus, that is 8 plus 8 j hat. Okay, so there we have it. So we have these two vectors. That is vector C there, 5 I hat plus 4 j hat, and then we have vector D here, which is negative I hat plus 8 j hat. Okay, they want us to draw these two vectors. Okay, draw these two vectors. Let me try and draw it here, where somewhere in the middle where I can see both of them. Okay, let's do this. I need to draw. No, I'm gonna use a clean page. This is still good. This is question A, right? No. A, yes, this is still A. Now we are still with question A. Let me draw it here. It's just a rough sketch. You can do it to scale by yourself. Okay, so vector A is 5 plus 4, so it is 5 in the I hat direction. This is the I hat direction. This is the j hat direction. This is negative j hat, then negative I hat. Okay, so there we have, it is 5 in the positive I hat direction, 5 in the positive I hat direction, and then 4 in the positive j hat direction. So there, 5 in the positive I hat direction, here 5, and then 4 in the positive j hat direction, 4 there. So there we have the first vector, vector number C. This is vector C. Now they're asking us to draw also vector number D, which is A, which is minus I, so it is minus in the I hat direction 1 there. So it is 1, but 8 upwards. Let's say that 8 is there. I know this is not a scale, so let's say 8 is there somewhere. But 1 is here, negative 1. So it is somewhere there, where these two intersect. So there would be D, vector number D. It is not to scale, remember? Not to scale. This is not, so it would look like that, not to scale. Okay, so it would look like that. Okay, so we're done with A. B asks us, question B. B asks us the following. Okay. Calculate C and D in terms of unit vectors. Okay, so we have them in terms of these vectors, okay, which we've calculated A. We've already calculated them in terms of unit vectors. We did that first, and then we draw the vector sum. We've already drawn the vector sums based on the unit vectors. Okay, but if we were to draw it originally, we would just add vector A, vector B, and then tail to method, the tail to head method, the head to tail method. Okay. So what we should be doing, we've already drawn it, we've already calculated the unit vectors of them. Calculate C and D in terms of polar coordinates. Okay. Now, in terms of polar coordinates means we need a magnitude and an angle. Okay, so what is C? We have calculated C. C is equal to, it is equal to, I have 5 I hat plus 4 j hat. This is C. D is equal to negative I hat plus 8 j hat. That is D. Okay, now they want us to determine them in terms of polar coordinates. Now in polar coordinates we have a magnitude and then an angle. Okay, so the magnitude of vector C is equal to square root of 5 squared plus 4 squared is equal to 25 plus 16, which is equal to 25 plus 16. It is the square root of 25 plus 16. Let's see, that is equal to 35 41. So 41 is between 6 and 7, so it'll be 6 point something, 6.4 to be exact, if my notes are correct. 6.4 units. What is the angle? Okay, the angle would be that over that, so the theta would then be the second function tangent of 4/5, if I'm not mistaken. And yes, guys, I do make mistakes a lot, actually, but I try to make as few as possible when tutoring. That's why I go over the work beforehand. So it is 38.7 degrees. So vector C is equal to 6.4 units at an angle of 38.7 degrees. Remember when we drew this vector, okay? This vector here. So it will be 6.4 units, but at an angle of 30. What did we calculate? 38. So the angle there would be 38.7 degrees. Okay. Now what is this angle? Yeah, we'll calculate that angle now. Okay. So the magnitude of vector D is equal to the square root of 1 squared plus -1 squared plus 8 squared, so it's 64 plus 1, which is just 65, square root of 65, which is between 8 and 9. So it's 8.06 units at an angle of second function tangent of 8/1. It is in the second quadrant. So 8/1. So it is 180 minus that, which gives you that theta. It's 180 minus the second tangent of 8. And it is going to be 180 minus the second function. Let me just check what the tangent is. I might have second function tangent of 8. '82. So it is 180 minus 82.9. 82.9. Okay, so that leaves me with an answer of an angle of, so second function tangent of 180 minus the inverse tan of 8 is just 180 minus 82.9, and 180 minus 82.9 is, let's see, 180 minus 82.9. It's 97.1, so the angle is 97.1. So theta is equal to 97.1. That is theta. The original angle is, yes, 82, but theta is 97.1. So this angle here, where is it now? The angle going from there, the positive x-axis, to that value is 97.1. Okay, which makes sense because it's just slightly after the 90-degree angle. Okay, now let us continue with the revision on vectors. Okay, we'll make this, the other one, our last problem. Okay, first I want to go out here because I will not be coming back to Moodle. I just want to log out quickly. Okay, so Now we have question number C. We've already done the angles. Okay, number 27, number 27. If you do not understand any of the work that I've done, please ask in the next session with either one of the demis. But these are just practice problems. Okay, since Dr. Desra wants you guys to start working on problems like these, we'll do practice. Problem number 27 for practice. It's breaking a vectors into components. Okay, so we'll break them into components. I just need to check something here. Papers. There we go. Okay. Problem number 27. Okay. A novice golfer. Okay. Guy just golfing for his first time. On the green, takes 3 strokes to sink the ball. Okay. The successive displacement of the ball are 4 meters to the north, 2 meters northeast, and then the last one, they are 1 meters at 30 degrees west of south. Okay. Okay, so let me try and draw what is happening. So this will not be to scale. So this first, it is 4 meters. It is already drawn there, but I'm going to try and explain the drawing. Okay, so it is 4 meters north. Okay, so 4 meters straight up. Okay, then he hits it 2 meters northeast. Now northeast is exactly 45 degrees. So let's start here. So we end there. So the next point is where this is where you will start. This is the original starting place. We draw that there. It's the next starting place. Now northeast is exactly 45 degrees. Okay, and it is 2 meters. This is 4 meters. This is 2 meters. And that is an angle of 45 degrees, meaning this will also be 45 degrees. Okay, then there we draw this. Please do this all the time so you can keep track of your angles. Now it says he hits the ball 30 degrees west of south for 1 meter. So 1 meter, 30 degrees west of south. Now this is south. Okay, now west of south, this is south going down this way. Okay, west of south would be this direction, somewhere here. It is southwesterly direction. Okay, but 30 degrees west from south. So the angle would be 30 degrees west. So the angle would be going this way. Okay, 1 meter, but 30 degrees west from south. So if this is south, then 30 degrees west of south would be from south going west, and it would be 30 degrees. Okay, there is just a small explanation there, but yeah, now you have more or less understanding of how he's hitting this ball. Okay, so starting at the same initial point, an expert golfer could make the hole in what single displacement? So this is the hole. There, he took 3 tries, so they want the resultant vector from here to there. So all you have to do is to break all of these vectors into components wise, and then add all the components and then find the resultant. Okay, so they want the resultant, this one, this vector here, r, vector r. Okay, now vector r is just equal going to be, vector r is equal to rx components, vector r, the magnitude of vector r is going to be rx components plus ry components squared. Okay. It's the sum of ry components and the sum of rx components. Okay, the total rx components. So the total distance, it goes in the x, the sum of the distance in the x and the sum of the distance in the y. Okay, let me write it neater. Okay, so it is the sum of the distances in the x plus the sum of the distances in the y direction. So in the x component, so let's say vector, let's call this vector number 1, let's call this vector number 2, and let's call this small one here vector number 3. Okay, so for vector number 1, let's break it up into its components. Okay, let's see there, its x component, and it has a y component. Okay, a y component. Okay, so let's go. The x component for this vector is, for the vector going straight up, vector number 1 is the vector going straight up. Okay, so it has no x component. Okay, so its x component is 0. Okay, so it's x, so rx1 is equal to 0. Okay, rx1 is equal to 0, but it's ry1 is equal to 4 meters, because it's only going upwards, 4 meters. Okay, now the next vector, vector number 2, is the vector that we need to actually start calculating now, because it's a 45-degree angle. Okay, that vector is at a 45-degree angle if we ignore all the other vectors around it. Okay, vector number 2 is just a 45-degree angle, 2 meters. Okay, so this is vector number 2. It is at a 45-degree angle, and that is all there is to it. Okay, this is vector number 3, by the way. I like to draw vectors as individuals. Okay, ignore all the clutter around them. So this vector would be 30 degrees from the north there. This is vector number 3. It's 1 meter. This one is 2 meters. Okay, this is 1 meter, and that is 30 degrees. Okay, so there are these 3 vectors. Vector number 1 is just a straight vector. Okay, vector number 2, let's look at vector number 2. If we want to calculate the horizontal components of vector number 2, okay, we use the cos of 45 degrees. So the cos of 45 degrees is equal to rx2 over 2 meters. Okay, so rx2, and that is ry2, that is ry2, that is rx2. Okay, so rx2 is equal to the cos of 45 is equal to rx2 over 2, which means rx is equal to 2 times the cos of 45. Let's see, what is the cos of 45 in the calculator. Okay, the cos of 45 degrees times 2. Still, I can't remember my special angles anymore. It's 1.41 equal to 1.41. Okay, now for vector number ry, it is the sine of 45 degrees. Okay, ry is the sine of 45 degrees. ry2 is the sine of 45 degrees is equal to ry2 over, what is the length? 2. Okay, which means ry2 is equal to 2 times sine of 45 times 2. It's 1.41 also. Now vector number 3. Okay, let's see vector number 3. This is vector number 3. Okay, so we have an angle there of 30 degrees, and rx2 will then now be rx2, the sine of 30 degrees is equal to rx3, sorry, that's rx3, and that is ry3. It's rx3 over 1, so it is just the sine of 30. Okay, what is the sine of 30 again? The square root of sine of 30 is the square root of 3 over 2. It's 0.5. It's a half. Oh yeah, sine of 60 is that. So it's a half. So rx3 is equal to 0.5. The cos of this vector, will give you ry3. So the cos of 30 is ry equal to ry3 over 1. So it is just the cos of 30. .87. It is 0.87. So ry3 is 0.87. And I think I made a slight error. Sine of 30. I made a slight error somewhere. That one should be negative. ry3 should be a negative. The cos of 30. Cos is negative because that vector is going down. That is the tan. That is everyone. Let me see the cos diagram. Oh, sine, tangent, cos. That is in the tangent domain, so it is negative. The cos and the sine should both be negative. This should be negative and that should both be negative. Okay, so we have values. Okay. I just know that you must know why these are negative, because that is in the second quadrant, that vector is in the first quadrant, this vector is in the third quadrant. Cos and sine are both cos and sine are positive in the first quadrant, sine and cos are negative in the third quadrant. Okay, so now we just need to add them up. Okay, so we need to add all of them up. We'll have the sum of r in the x direction, and we'll have the sum of r in the y direction. Okay, that is 0 plus 1.4 minus 0.5. Okay, that is 0 plus 1.41, which is 1.41 minus 0.5. That is 0.914. Okay, so this one, no, sorry, it should be 0.91. I don't know if this was not here. Let me see. 0.4, 0.5, 1.41. I did it calculatively. Minus 0.5. .91, yes. So it's 0.91, and this one is then 1.41 minus 0.87 plus 4.5. 4.54. So there we have the sum of the components in x direction, the sum of the components in the y direction. Okay, now we want r, the resultant vector. Okay, so we want r, the resultant vector. Okay, r, the resultant vector, and we also want theta. Okay, so r is then equal to the square root of the sum of the x components plus the sum of the y components, both of them squared. Okay, so this is equal to the square root of 0.91 squared plus 0.9 plus 4.54 squared. Okay, gives you, okay, let me just erase here. Okay, next one, 0.91 squared plus 4.5 squared gives you equal to 21.4397, square root of the answer. 21 point, I'm just doing the calculation here, 4397. I'm just making sure that I actually did it correct. 4.6. Okay, so let's see. Yeah, that is what I got originally. 4.64 meters is the magnitude of this resultant vector. So an expert needs to hit it at for 4.64 meters, but at what direction, in what direction? So we know what that value is there. The x component is 0.91 and the y component is 4.54. Okay, so theta would then just be equal to, theta is then equal to 90 degrees minus, so we want that theta, we want this value from the positive axis, that one there. Okay, phi, so phi, we want phi is equal to 90 degrees minus theta, okay, which is 90 degrees minus the tangent, the second function tangent of 0.91. No, that is the 0.91, yes, over 4.54, which will give us an answer of 4 points the other way around. Sorry, it is, just switch them around. It is theta, let's say, let me just draw it this way rather. Theta is not that one, theta is this angle here, so theta will just be, theta is just then this angle. Theta is equal to that angle there. This is the vector, okay, this is the vector, this is theta, and we've calculated that to be 4.64, its magnitude, so we want that angle theta, so it's going to be that ry over r. Second function tangent of ry, which is 4.54 over 0.91, and we give it equal to 78.6 degrees. So it's going to have a professional has to hit the ball for 4.64 meters at an angle of 78.6 degrees. And that, ladies and gentlemen, is all that we have time for today, because load shedding will be happening in a few minutes, and I'm supposed to be ending the session at 2. So by now, as we have covered a decent amount of work on vectors, and we finished the tutorial 2. I hope to see you next Friday, and if you have any problems, please contact one of the demis, not the demis, the instructors, and they will help you along, or the tutors. I hope you have a great weekend. That is goodbye for now.